Okay, let's get started. So today's lecture is fairly open-ended. So it's one of them lectures where if you have questions and stuff, let me know. Actually, all next week is going to be pretty open-ended too. So if there's stuff you'd want to see that might take some time for me to prep, if you let me know now, I can get ready for it next week. Next week and then another week towards the end of the semester are pretty open-ended weeks. There are a lot of topics that I like to cover during those weeks. I have a lot of content that I really want to show you through those weeks. But the order isn't too important because none of them show up on the homeworks. And I'd be willing to add different things to those weeks. So if there's anything like, I didn't plug in my laptop was the issue. Oh, crikey. So if there's anything like, man, taking a course named Web Applications, I really expected to see this or whatever. Let me know what those things are, and I can get them into one of those 2 weeks. Today I want to go through the WebRTC stuff. We'll wrap up the WebRTC content. You have everything that you need to do WebRTC, but I want to go through the JavaScript code that I give you. Just explain a little bit more about what you're doing for Objective-5 and how that fits into the code that's provided. A quick bit to go over video streaming, even just recommended resources that we can learn. That kind of stuff would be great. Ooh, I like that. I can do a little bit right now, and it depends on what you mean by video streaming. It's one of them terms that's overused a bit. I'll assume you mean like live streaming, like if you're live streaming on Twitch or YouTube Live or whatever other live streaming site you have. Generally how that works is your server is going to have an ingest side and then I forget what the other side's called, but another side where you're delivering the content. So you'll have the users send their raw video feed to you, and then you're going to convert that into formats that are suitable for consumption of the end users. So you're going to get, I want to say RTMP, I don't know if that's the right acronym, but you're going to get video, raw video, in a format that something like OBS is going to send to your server, process that, save it, and usually in HTTP streaming protocol, HSP maybe? That doesn't sound right. But then save it as a different protocol that's suitable for streaming. So I might go over this in more detail in a later lecture, like I said. But if I don't, I want to make sure I at least get a good amount of information out there. Do I have any? Genetics, public. Maybe I have it over here. Wrong kind of encodings. I have some examples, but I might have got rid of them. I feel like the protocol is HTS, though. But it's a format that's suitable for streaming because you can save a video in different qualities. So when you go to a player online, you expect to have different options for quality. So if you have a weak internet connection, it'll just drop down to like 480. If you have a strong internet connection, it'll bump up to HD. So you take the raw video that the users send you, and then you convert it to this format where you're saving the video, processing the video into multiple different quality levels, and then storing some information about which, how do I want to word this? You're saving it in multiple files, like the first 10 seconds or so of the video will be saved as a separate file, and then multiple of those files for each, one for each quality level. And then you'll have a file that's going to organize, remember which file names are for which parts of the video. And then when the users request it, they'll get that I think it's called the manifest, they'll get that meta object, that's what you're going to send them, which says, here are all the file names for the different locations of the video. And then the user can select their quality level and then request the appropriate files for the content for that quality level for that time frame. And then keep making requests for those files at that specific time frame. And then when they run out of files, they'll request a new meta file and then read that file list, request the right files. If you switch the quality, it's just going to start requesting different files from that. So the server is going to store all of those files as those tons of files for a single stream, and the users will request those files. So it's not strictly live streaming the way we consume things like YouTube, Twitch, any live streaming like that. It's not strictly live. You'll be lagging behind by a few seconds. You can see that whenever a streamer says, like, type 1 in chat. Like, there's a little delay. There's a second or two before the first ones pop up. It doesn't take people that long to hit 1 and enter. But you'll see that delay, and that's okay. Usually we're okay with that when it's one person streaming to a large audience. Usually that's fine, that's acceptable. So that's how it works, is ingest, process, and then host all those video files for the users. And if you go to a streaming site, let's go incognito. Is this dangerous? It's going to suggest Amaranth right away. Oops. Why didn't I open this in Opera? But if we look at the content being requested, it's going to be a ton of AJAX requests. Let's get past the ads so we can actually get to the streaming. It's going to be a ton of AJAX requests to request all of those files that I just mentioned. So we're going to have these, a request for try to get one that makes sense. This M3U8, that's the format we want. I'm not going to get to look at anything, though. Oh, I'm sure. Where do you see the Amazon one? Oh, yeah. Yeah. It's hard to say. Amazon owns Twitch, so they're going to have their fingerprint all over it. Mm-hmm. That's why you're Amazon Prime, you can get a Twitch Prime for free. Yeah, I guess if you... well, I'm having trouble finding anything useful here, but this is all video content. I'll just explain the theory behind it. So this is all video content. Some of these are going to be requests for those meta information files. Oh shit, I forgot to do a lot of these are for meta information files, and then a lot of these are content. So you're getting one bit of content at a time, but it's all happening through AJAX requests. There's no like stream, like we're not using a TCP connection, like one stream like we are with WebSockets. It's a whole bunch of HTTP AJAX requests. And I forgot to do this lecture question. Should have done it 6 minutes ago. A couple of you got lucky there. But I want to do the lecture question before we get into just going through some code and doing things. I got all wrapped up in video streaming and forgot about it. Damn it. Ooh, how browsers work. Doing a lecture on how browsers work would be interesting. Great. Anybody need more time with this? Okay. Yeah, doing a lecture on how browsers work would be interesting. I don't know how browsers work, so it'd be interesting because it would force me to do some research, which would be fun. And am I familiar with how any websites that are particularly impressive, technically speaking, work? So what I just described is how Twitch works. Twitch has a document out that explains how the Twitch architecture works. And it's very similar to how YouTube Live works as well. So I'm familiar with that at some level, but not to like any true depth, I guess, if that makes sense. But I know the high-level architecture of those sites. If there's a site that you would want to see, want me to explain how it works, that would, again, force me to do some research on how that specific site works. So if there's a specific one you'd want to see, I think that would be interesting. Yeah, I understand since I showed it late, if somebody's dishonest about that answer. Well, I forgot to do it. Yeah, I might prepare more streaming stuff. I could probably do that. I might be able to do that next week. And then how browsers work would be interesting as well. MB Pings? Is that a website? I don't know if that's what you meant. Not a website. Bad for the ping. I think my brain missed what you're saying there. All right, so let's talk about some WebRTC stuff. So first, I want to show what I forgot to demo last time. I'm going to fire up my server, go to Opera, go to Chrome. Visit my site, start my video again. Can I dodge my video? I actually brought my webcam today to make this more impressive in the demo. It didn't work. The browser wouldn't let me select which camera to use. It would just always default to one. But so we'll do the same camera again. I'm going to start my video chat, and then I'm going to go back to my server and shut her down. I'm even going to kill it. So my server is no longer running. My server is not serving content at all. But when we go to the browser, we expect the first video to work because that's just local. But we also see the streaming videos working as well. It's live. It's what's happening right now. This is a true peer-to-peer connection. My server is done. Once it sends those signals to establish the connection, my server is not involved anymore. This is a UDP connection between my two clients right here, and the server has nothing to do with it. I shut down my server. We proved that this is a true peer-to-peer connection, which is what we wanted. This is great. Yeah?
Which video is which?
So the top one is the local one, and then the bottom one is the one that's being streamed in. So this video is being captured from my webcam and then being sent over here. And then this video is being captured from my webcam and being sent over here. So the two bottom videos should lag behind a little bit. And then it's even more trippy because I have in the background I have it. You should be able to see. It's just a little bit behind. It's milliseconds because it's all localhost, but.
And it's also getting sent to the same, it's like, where's it actually going now? It's the same computer.
It's the same computer, but I have and then the page won't reload because my server I shut down. But it's a UDP connection connecting two of my internal ports to each other. So it's using the same technology as it would use to go from my computer to a computer in China. It's the same exact technology. I'm just really overkilling what I'm using that technology for because it's just staying local to my computer. Just for the demo, but.
Port's different though, because they both say 8,000.
The ports connecting to the web server, to connect to the signaling server, were the same port, but when it was a UDP connection, those were two different ports, one for each browser. Okay, so let's talk a little bit about how that worked, and I should have some good information in here that we can look at, captured from that connection. So one, something superhero T.A. Nicholas pointed out is this beautiful line, which I never knew about until Nicholas told me like last week, and I added it to my code. If you add this line of code to your Python code, socketserver.tcp server.allow reuse address equals true, this is going to get rid of the issue of the port being already in use. This will release the port immediately, and you won't have to keep changing your port numbers like I was even doing in lecture up until last week. I'm finally done with that, and you can be too. Just add this line of code right before you start up your server. Or I think it can be after as well. But before you go into serve forever. Set that to true, and that will save so much time on both of our sides. I should have took the credit. I did forget. He told me and showed me the code, but I forgot. So I did have to find it on my own for what it's worth. I should take credit. Oh, it wasn't you? Oh, I didn't read your message. No, it wasn't you? Wait. Well, then I figured it out. I'll take credit. All right, so set that to true. It's going to save us all a bunch of time. I swear it was you. I don't know who it was then. Nobody else is taking credit? All right. So I want to look at a few things. I want to look at the messages. I changed what I'm printing out to just print out the messages from my WebSocket frames to see what these WebRTC messages look like. And first, I got 6,100-ish bytes of a WebRTC offer. So we can see that these are going to be fairly large, like they're not going to fit in your less than 126. They're going to hit your second stage of payload length. So we have to have that payload length working well before we get to Objective 5. The WebRTC offer, the JSON structure here, we're going to see in a bit. This is built by me on the front end. And then this offer object here, this is what the front end with the browser generated. This is generated by the browser, and we can look at what it is. A lot of it doesn't make sense to me. It would take some research into how video coding and coding things work. But we can see a few things. I know this is localhost. We're using IPv4. There's going to be the ID in here, somewhere in here. Somewhere in here. The UFrag, this is going to be the ID of the user, which was mentioned in the slides. This will uniquely identify this user for the connection. So when two users are connecting, they can look at the UFrags and make sure they're connecting to the appropriate user. Whenever I've seen them, they've been 4 random characters like this. So not a ton of entropy in these. But that will uniquely identify this user. I believe for this server, this can't be global. That's not enough entropy. And then a whole bunch of other values here. A lot of this has to do with video encoding and then API calls to make. I don't know if there's anything else that I want to pick out of this. We're going to use UDP. The UFrag again. It's getting repetitive. I don't think there's anything else I wanted to pick out of this, but just in case we see something interesting, which I don't see anything more interesting. I mean, this is interesting to someone. It's not interesting to me from a WebRTC signaling server standpoint. But you'll have this offer, which was generated by the front end, and we're just going to forward that to the other client. The client is going to get that and then respond with an answer. Again, the JavaScript here is built by me, and then what the answer actually looks like is all this stuff. It's going to be the same information that was in the offer. It's going to be the same information that was in the offer, but now from the client side. So we can see these mirroring each other quite well. It's going to be the same type of information. There are going to be some different values, but we got the same type of information. Here are all the video things that I use. In this case, it should be almost identical because it's the same machine, it was different browsers, so it will be a little bit different. But same machine, a lot of these things are going to be the same, except that ufrag. Let me go back to the beginning and take a look at that ufrag. The ufrag, of course, will be different because that's going to be the ufrag for this user. And somewhere in here, ICE options, ICE password. Did I pass it? I must have passed it by now. Candidate answer. Right here. So R2C7, where the ufrag for my other user was NJ82. So we got two unique identifiers, so that's going to be how we're going to identify each one of these two users. Not us specifically. For the homework, it's simplified enough that we're just getting a message and forwarding it. But this is how the users are going to identify each other, or if we had more than two users connecting, that's how we would identify them, is by their ufrag, or by their WebSocket connection, honestly. And we're also going to get these candidate messages. Now the candidate, every time I've seen it, I'll say it in general that you can receive multiple of these, but whenever I've seen it, it's been like 3 or 4 of these messages, but you'll get multiple candidates from each user. So we're going to get these candidate messages, which we need to forward to the other user. Again, the JSON format is mine, and then what the browser generated was this part of the candidate. This one's small enough that I showed a whole candidate on the slides last time. That's the whole candidate, much smaller than the offer or the answer. And this has some of that connection information. How are we going to connect with each other? And this should say a few things. The ufrag, of course. The connection type, UDP. My IP address, which it looks like I got a V6 IP address, and the port number for this connection. So this is saying, hey, this is what I got from the stun server, or sometimes I see localhost IPs in here. I think I looked into that a bit. I think that's when the stun server isn't even required, when we're just not even going to the stun server. But IP and port, and we should see multiple of these. We have another one right here, UDP on this IP and this port. Okay, those are different ufrags though, so that's one from each user. Where am I? So here's the first candidate. So we have one from NJ, one from R2, and then we have another one from R2. So we have a second candidate from R2. This time we got an IPv4 IP address with a different port number. So it's saying, look, you can connect to me on this IP and port using UDP, or this IP and port using UDP. Here are multiple candidates that you have at your disposal. I'm fine with either of them, but here are your candidates that you can use. And then we didn't get another one from the other user. And then you'll also get these candidate null messages. If you want to edit my JavaScript and not send these nulls, I think you get away with that. But we're also going to have these nulls when there's no more candidates left. When you try to generate another candidate and there's no more candidates to generate, you get this null, which is, hey, no more candidates, that's the end of my list. I don't think they need to see this on the other side, but they might. I like sending them to be sure, but I haven't tried it without them. But you'll see these nulls. which will be the last candidate that you get from each user. So those are all the messages. Those are the actual messages, the actual content. It's all text that's going to be sent by your signaling server. One offer, one answer, and any number of candidates. All right, now let's see where these things came from. I got a little more than 100 lines of JavaScript. I'm going to go through the whole thing. Why not? We should be able to get through the whole thing, at least at a high level. So we have creating our WebSocket connection. Some of the first part is just WebSocket stuff, but I don't think I went over this yet, so let's start right from the top and go over the WebSocket stuff. This line right here, I did talk about before, but just to be clear, this is going to create an HTTP request and send it to your server. That's going to be the upgrade request. And then once that handshake is done, we're going to have a reference to that socket returned from that new WebSocket. And then we can use that reference to specify what we're going to do when we receive messages and to be able to send messages to the server. So when we want to send messages, we just use send, give it a string. The browser is going to do all the payload length and the masking, all that good stuff. It's going to create a WebSocket frame with the text that we gave it, give it an opcode of 0001 because we gave it text, and then send that WebSocket frame over to our server. All that's happening in a pretty straightforward call from us, and then the browser does all the heavy lifting for us, sending that WebSocket frame. When we want to receive messages, I'm going to go out of order, but I'll cover everything that I just skipped over. We're going to use the socket.onMessage callback and set this equal to a function. This function is going to be called with the content, the payload of any message that we receive from the server. So again, the browser's doing all the heavy lifting. It's getting our WebSocket frames. It's decoding the payload length. It's checking the types. It's checking the fin bit, extracting the content of the message that we're sending, and then calling this function with that content, with just the payload. They don't have to unmask because we don't mask content from the server, but getting just the payload and then calling this function with that payload as text, decoded as text. So this function is whatever we want to do with WebSocket messages that are sent from our server. The way I have this set up is I'm going to use JSON for all of the information being passed back and forth. So I'm going to parse the data of that message. Oh, I guess we do get more information, but I'm going to parse the payload as JSON, and I'm going to access the message type. Anything that the client sends to us or we send to the client is going to be a JSON object with a message type key, and that's going to let us decide how we're going to handle this message type. If you've ever used oh my goodness, the WebSocket library, like the WebSocket library. What the hell is that one called? Can't believe I'm blanking on that. I can't believe I'm blanking on it, but it's like the WebSocket library. If you've used WebSockets, you've used this library. I can't believe I'm blanking on what it's called. But that builds in a messaging system into it. So if you've used WebSockets before, you're probably used to this messaging system, this message type system. That's not a part of WebSockets themselves. That's a part of that library that we use, Socket.io. It's a part of the Socket.io library that adds that message type. Since we're not using the Socket.io library, we're using raw WebSockets. We're going to add our own message type to get that same type of functionality in our code. So I'm going to add that message type, and then based on the type of message, I'm going to handle these things differently. It's either a chat message from objectives 1 through 4, or it's a WebRTC offer, answer, or candidate. And if it's none of those, well, something broke. So that's how we're handling our socket. We're using send to send information, and then on message to be able to receive information and handle that message, those messages that we receive. This one I don't really want to explain, but it's whenever the enter button's pressed, I'm going to call send message. So when you're chatting, you can just hit enter instead of clicking the send button. That one I think is pretty self-explanatory anyway. Yeah.
Is that calling a Python
What? No. This is all JavaScript. This is all front end. Everything here is front end. Oh, which part were you referring to, though? The on message? Or any of...
For my project, I'm trying to figure out if it's okay to call Python from JavaScript.
Not on the front end. You don't have access to Python on the front end. We only have JavaScript. But these will make, like, once you send a message, on the other side, your server's Python is going to receive this, extract the payload and all that. And then it'll be in Python. All right. We got that. I'm declaring a variable WebRTC connection. We'll populate this and use it throughout this code, but I'm just declaring the variable right here. So I have it available in all of my functions. To send a message, I'm going to grab the content from the chat comment. I'm going to blank it out. I'm going to put the focus back on that box, so you can just type, hit enter, to use the chat. And then as long as it's not the empty string, I'm going to send that message with a message type of chat message, and then the comment of whatever the comment was. I have to add things like check if it's empty string, because whenever I have a demo where I have a live chat app in class, there's always at least one person that just lays on the enter button and just holds it down and sends a billion messages to the chat, and it gets annoying. And then I add that, and then they just hit one letter and then enter, one letter and enter, and I don't know. Students do some silly things sometimes. But if we check to make sure that it's empty, that it's not empty before sending it, gets rid of some spam. Add message, this is when we get a message from the server. We're going to get the chat div and then render that new message to the bottom of the chat div. It's important to have plus equals, not equals here. We're just appending this HTML to the end of that div. So we can just see the new messages as they come in. And then get chat history, we're going to use an AJAX request to get everything that, all the chat history, all of the previous chat messages. So when the page loads, we're calling get chat history, make an AJAX request, iterate through all of the messages, and call add message for each one. And then after that, we're only rendering messages that we get over, the new messages that we get over the WebSocket connection. So we're combining AJAX and WebSockets to be able to get the full functionality of our site. And we're back to handling messages. When we receive something of type chat message, we're just going to add it with the code that we just seen. And when we get WebRTC messages, things are a bit different. And again, I'm going to go out of order here and start way down here with welcome. So welcome, the first line looks familiar. You've all seen this extensively. This is going to be called on load. So when the page loads, I'm going to tell it to call welcome. Welcome is going to add hello from JavaScript. Yay. And call get chat history to fire off that first AJAX request. So I can get all that chat history rendered to the screen. I have a line commented out here. This can help you when you're testing your WebRTC, your Objective-5 stuff. If you comment this out, it's going to call start video immediately. Whereas in all the demos that I showed you, you have to press the start video button. That start my video calls start video. So if you don't want to have to click that button each time, you want to take one step out of your debug cycle, just uncomment that in the welcome function, then you don't have to click the button. Saves you 2 clicks. Yeah.
Is connect WebRTC, is that the handshake?
Yeah, it's going to start the handshake. So, and then the other button is going to call connect WebRTC.
That starts the handshake.
Which will send the offer.
How does it know who to send it to?
The server. There's only one server. Then your server is going to figure out who to send it to after that. So start video. Let's do start video first. It's just these 2 functions, right? Oh, yeah, we're making great time. Let me check chat a bit. It was socket.io. Thank you, Latitude. Next week, things to make an application more seamless, intuitive would be cool. I'm not positive what you mean by that. Make an application more seamless, intuitive. Like on the front end? Yeah, if you can follow up with some more details. All right, so start video. This is where we finally get into starting the video. I don't know where that sentence is going. So first, when we start the video, we're going to have to specify some constraints. This is going to specify whether we want audio and or visual. I want both, so I'm going to set both to true. The constraints, this get user media is going to expect constraints to be an object with this format, an object with keys, video, and audio, mapping to Boolean values. So I'm going to give it the information in exactly the format it's expecting. Get user media, this navigator, media devices, get user media with the constraints. This is going to access my webcam. So if I go to, see if I can do this. It's not going to work because constraints isn't defined. Cannot read properties. All right, it's going to make me actually do it. That's fine. I like that. I want it to do that. Video true, audio true. Hold on, we can do this.
Are you just running the server file or are you using Docker?
I'm just running the server file. So I have an issue. Is that I already allowed it. But as soon as I run this line of code, I'm asking the browser, hey, give me access to video and audio in this line of code. So once I hit this is where I'm going to get the warning, where your users are going to get the warning, and you'll see this in your Objective 5, where you're going to get the warning of, hey, this website wants to access your video and audio. Are you going to give them access? And of course, for testing, we want to click Allow. And then once we have that, then we have access to the user's webcam and microphone. So that's when you get those pop-ups like that. There's some line of JavaScript like this in the web page that you're accessing that's trying to access your hardware. Yeah.
Are audio and video the only two parameters?
There are other settings, but those are the two inputs that you can receive. I think those are the only two like media that you can get.
They're hard-coded in video, audio, and...
Yeah, I think there's other constraints you can add. Oh, we're not going to get to see the code. I think there's other constraints you can add, but those are the two like things that you can access. I don't think there's a third thing you can access. So we already have access to like keyboard and mouse and touchpad. What else would we ask for? So this is going to access that webcam and microphone, and it's going to return a promise, which is going to give you that information, all that content, all that media as an object, and then we're going to define what we're going to do with that. So at this, and then the first thing I'm going to do is access my video div. So in my HTML, I have this my video. Oh, sorry, not a div, it's video. I'm going to access that element, and I'm going to set its source object to that stream that was returned. These 4 lines are all you need to do to play local video. So if you want to access somebody's webcam and just show their webcam to themselves, or you want an app that's going to record their audio or like echo their audio back to them, I don't know why you do that. But if you want a website that's effectively a mirror, this is all the JavaScript you need. This is it. Everything else is for WebRTC. Everything else in this file is for WebRTC to make that remote connection with another client and to send this video to somebody else. Yeah.
If we wanted to record their audio and maybe put it in the database or
You would have to route this stream to something that's going to save that. So we're routing this to use WebRTC. You would have to use some other technology and route it somewhere else.
so you're just going to send that variable to the client, to the other variable instead of manipulating it. You're just going to take it and send it.
So right here, I'm displaying it to the user themselves, and then the rest of this, we're going to send it to the other user. So we have to set some configurations. We're going to set up the ICE server, which I found out is when you're testing locally, I don't think the ICE server is used at all. I think that's the specifically when you're testing with localhost, that there are different things that happen. One of those things is not using the stun server, and that's why I was seeing local IPs in one of the lecture examples. It's not always using the stun server. It's not always necessary. It's not always required. But we're going to specify it for when it is required. We're going to have it ready. We're going to hard code that Google stun server, that publicly available one. We're going to create an RTC peer connection with that configuration. And this is where we're first going to use that variable that we declared way at the top of this file. We declared that variable and didn't do anything with it. Here's where we're finally assigning it a value. It's going to have a reference to our peer connection. I'm going to add my stream to that peer connection, and then specify a callback for what happens when a stream is added, importantly after I add my stream. So when a second stream is added, which will be from the other client, we're going to set that stream to the other video, which is just the other video. So my two video tags, the two that we see playing, the other video is going to be set to the stream of the other user. So whenever we have any other stream added, this callback is going to set that equal to the other video element. And then whenever we get an ICE candidate, this is another callback that's going to be called whenever an ICE candidate is ready. This is going to be called. And what we want to do whenever an ICE candidate is ready is send it over our WebSocket with a message type of WebRTC candidate. And then the candidate is going to be whatever the browser gives us as the candidate. We're just forwarding that information to the signaling server. Signaling server is forwarding it to the other user. And we don't really have to care what's in here. We did just look at that in the logs in our server. But for our purposes, we're just going to send that on its way. We don't have to crack that open and read what's in it at all. So whenever we get a candidate, send it to the server. And when we call that connect WebRTC, when we click the connect button, we're going to create an offer. Go to our connection and create an offer. This is going to give us the offer, which we're going to send over our WebSocket to the server in this JSON structure. When I kept saying, I'm creating that JSON structure, and I highlighted that part, that's what I mean is I'm saying, like message type is something I'm creating and giving it a message type of WebRTC offer, and then setting the offer equal to whatever the browser gave me. And then I'm going to set my local description to that offer. That's going to make sure that my connection knows how to handle the video and how to send it out. And the last piece of this is when we receive an offer, we're going to set the remote description to their offer and then create an answer, which is going to look very similar to when we created an offer. Set the local description to that answer, just like we set the local description to the offer just now, and then send the answer to the signaling server. When we get an answer, we're going to set the remote description, just like when we got an offer. The answer and offer are very similar, contains mostly the same information. So we're going to set the remote description to that answer. And whenever we get an ICE candidate from the other user, stop doing that. Whenever we get an ICE candidate, we're going to add that ICE candidate with add ICE candidate to our connection. That's everything. We got through every single line of code pretty much right on time. Anybody have questions? Yeah. You send a message with 127 bits. Mm-hmm. You got to send with over 100,000 too. Just a long ass string. You just send it a string with size 126. I don't know what you're asking, what you're getting at there. You just type that many characters, and then send it. Or actually, that's not completely accurate because you have some overhead in the JSON format. So you have to do a little bit of computation. So anyway, so that's how the front end works. And then when you get these messages, just forwarding them to the other client is your task. You're going to get these 3 message types and forward them off. Have a great weekend. I'll see you Monday for Halloween.